So on your blue sheet, the last thing that was checked off was this guy here, transformations review. Now the next class, I was gone, so just going to put an X through that box. You're supposed to finish the SL packet in preparation for the quiz.
That's gonna throw off the points I deserve.
Yeah, it made 9. So you didn't actually do anything for me, -7. Alright, and then more SL practice number 1. So that was last class. Last class we did our practice SL. I didn't check homework just because of time. So go ahead and put an X through that.
I'm literally losing all the points that I just had.
I'm really grinding.
I went from, so like, I had like a 75%. Oh no, I have a 75% now. But I had like an 85% before.
Okay, so then what's due today is our more SL practice number 2. This one we are checking. Now, those of you that were absent last class, it'll be over in the tub day something. So if you were absent last class, go and grab that from the tub. Now, again, for sake of time, because there are quite a few little things I want to do before our lesson for today, is we're going to check homework doing shoulder partners. So in your shoulder partner, your assignment sheet and your more SL practice number 2. You are going to give your partner a score out of 10, but you need to write this in something other than pencil. So you're going to give a score out of 10. You will initial it with your initials, not mine unless your name is Jonah. Your initials. Give the score out of 10. Put your initials next to it. This needs to be written in something other than pencil. If you were absent back when we had our transformations review, you need that signature. Let me know.
I just got scammed under like 10%. I'm actually mad at Have he actually copied that homework off someone else? You should give him 0. I wasn't here. I wasn't skipping school. I was ill. Alright? I was on my deathbed, alright? And now I'm back here.
Okay, once you have given a score, go ahead and hand it back. So you should have your own assignment sheet. Double check that you have a score out of 10. They initialed it, and this is written in something other than pencil. Other than pencil. Okay, now what you picked up on your way in is a yellow assignment sheet. Well, we'll talk about it in just a moment. Chloe, do you mind to tell Sam what we're checking for homework and then just sign hers off?
This is the final exam.
Alright, so you picked up a yellow assignment sheet. I'm going to pull that up over here. Normally we were scheduled to go over the practice SL today, but I've had quite a few people gone for SL testing, so we are going to wait to go over that until we're a little bit closer to our SOL, because after tomorrow, I think I stopped losing people. So today we're going to be doing ellipses. So notice your homework for tonight is ellipses day 1 homework. It's not SOL practice number 3 that comes later. So we will be now working on the yellow assignment sheet from here to the rest of the year. So I'm going to go and collect your blue assignment sheets. Make sure your name is on that, and then I'll collect that to give you those points.
Aww.
But if you were absent last class, then you need to do the more SL number 2. Hold on to it, and then you can
Alright. I thought I just lost more percentage.
No, because you were here last class.
Dude, I thought I was about to get like a 60% on this. I'm saying.
Do you want to fast forward your assignment sheet? You know, get some free points. Kelly, congratulations. He's patiently stretching for you.
Doesn't even matter. Doesn't matter.
I'll grab it. Okay, so I have everyone's blue assignment sheet. Okay, so again, if you were absent last class and you're just not getting the SOL homework number 2, just bring it to me next time. Okay, so now we're taking a look at our yellow assignment sheet. Everyone should have that in front of them. So our yellow assignment sheet here, today we're doing ellipses. We're going to learn how to graph them. Next class, we're doing completing the square root ellipsis. We can get into a nice format for graphing. And then we'll go over our practice SOL. This should give enough time for all my makeup people to have finished it. And conveniently, this would be the day before your SOL. So your SOL is the 23rd, is that correct? 7th period.
Yeah.
So we'll be going over our practice SOL on the 22nd, and then the next day we'll be taking the SOL. Yes?
We're gonna eat ice cream on the last day of school.
If you bring it, we'll eat it. Okay. Now you can ignore this black thing, only because you guys are red days. So then after we go over our practice SOL, we'll pick back up with our ellipses. We'll review our ellipses, and then it's Memorial Day weekend, and then we take our ellipse quiz. And this is just a quiz. We'll still review a little bit to get and take our quiz. And then that's it for new instruction. We will then head into final exam review, which we've been technically preparing for because we've been preparing for the SOL, which everything on the SOL is on the final, but just a little bit more. So we will have a day devoted just to review the final. And then our final has 2 components. So go ahead and take a look at that packet you picked up. So this is your final exam review packet. You obviously don't have your final for another almost month, 3 weeks, but I'm going to go ahead and put it into your hands now so you can work on it as you so desire. This is not due until the day of your final. This is 7th period, so your final is June 6th, Thursday, June 6th. That's the first day of the final exams. So Thursday, June 6th, you'll come in, you go to your 5th period final for 2 hours, and come to 7th period final for 2 hours, and then you go home. Everyone leaves at 12:10. Well, you leave after the same grade. So you guys are on the 6th of Thursday. Now, our final exam, you'll see on that front page of your packet, has 2 components to it. The bulk of the exam, the multiple choice section, I think it says 50 multiple choice questions. Yeah. So 50 multiple choice questions, that's what you're taking on the final exam day where you have that 2-hour block. Prior to this, we will have a smaller free response portion. I feel like it's better to say short answer. These are like normal geometry problems where you don't have answer choices for you, where you just complete the problem and you can get partial credit for it. But there will be at least 1 proof. Okay, so I think it says 3 to 4 questions, at least 1 proof. The ones that aren't proofs are going to be our normal types of questions where you have to solve for something, but you can get partial credit rather than just right or wrong with multiple choice. That will be done the class before that, and that's not going to be the whole time. I think it might actually be 30 minutes because it's shorter than it was before, but I'll take a look at it. It's between 30 to 45 minutes. So you'll do that the day before, and we'll review the first half of the class and then do that. Now, for those of you that are going on the band trip, we just need to make sure if you are not here on this day, which I don't think
You're not.
7th period, are you? No, because you guys leave at like noon, right?
Yeah.
Okay. So then we'll figure out when to have you do it. Probably just the stinger before that, something like that. So we'll figure that out on an individual basis. So Bella, Demi, are you Marilyn too on this one? Okay, so we'll figure it out individually for you guys. Okay. Now, in terms of the grading for the final exam, the multiple choice is the bulk of it. So I believe that converts to like 100 points, and the free response I think is somewhere around 15 to 20. It's kind of out of like 120-ish points. So as you can see, the multiple choice is the main portion of the grade, and then there's a little portion that's free response. Questions with that? Okay. The final exam review guide, you do at your own pace. It is due on the day of your final, which is the 6th for you. The answer key is up on Blackboard, so you should check your answers like always with our reviews and see if you have questions. I would recommend you do some between now and your final, because during final exam review days, I'll ask if you have any questions on that homework, so that would be another good time to go over that. but you don't have to turn it in until the day of the final. If you'd like to turn it in beforehand, so I can mark you off and give it back to you, just so you don't have to worry about the day of the final, that's fine. Okay, and then this year, graduation is during the school day. It's at like 10 o'clock or something, so nobody comes to school on that day. So you have all of your final exams, 6th, 7th, 10th, and 11th. And then the 12th is graduation, so you don't come to school. And then 13th is technically the last day of school, but there aren't any finals on that day. That's just you come to each class for like 10 minutes and go home. Dismissal time, I think, is like 10 o'clock or something like that on that day. And then you have your summer. That's it.
Would you come to school for
What's that?
Why would you come to school for like 10 minutes?
You don't have to, but I'll be cool. I think what it was is back before SIS was a thing. People would come and they'd get their final grade. Like they would go to each teacher and get their final grade.
Wait, how long? You said it was 10 minutes?
I think you go to each class for like 10 minutes.
Oh, I thought you said overall was 10 minutes.
Oh no, that would be
that's crazy.
Okay, are there questions with our pacing? Now, our next stinger, we will be doing an extra credit opportunity, so keep that in mind. And at this point, I'm going to go and transition to my people that need to make up stuff. I'm going to get you guys started. The rest of you just hold tight for a moment. Okay. Let me start about ellipses. So ellipses, in your vocabulary, you would probably think of as ovals. We have the technical term, which is ellipsis, so it's a nice ellipse, not like an egg-shaped ellipse. You'll notice that our ellipses, when you look at your paper, if we were to split it in half, it would be 2 congruent halves, right? Okay. So today we're going to talk about how to graph our ellipses given the vertex form of the equation. Next class, we're going to have ones that aren't in vertex form. We have to complete the square, or to put it in vertex form so we can graph it. Now, completing the square is actually something that you learned back in Algebra 1 Honors, but I'll teach it as if you've never seen it before. So if you don't remember, or if you didn't have Algebra 1 Honors, then I will still teach it as if you've never seen it before. Just stop that. And you get to do it again next year. So this is kind of a nice little precursor / review from last year for something you're going to be using next year. So ideally next year, then when you get to it, it'll be a little easier. Okay, so first let's talk about what ellipses are. Let me go back to my first page of the notes here. Okay, so an ellipse is the set of all points. These are x, y points. Such that the sum of the distances between that point and 2 other distinct points is a constant. These other 2 distinct points, we individually call them a focus. The plural form is, let me make sure I'm saying this right. I thought it was foci, but it's apparently foci.
What?
Which is focus plural, so you'll hear me sometimes just say focuses.
Focuses, that's grammatically correct.
It is. So basically what we have in an ellipse is we have our center, and our focuses, our foci, are usually pretty close to the edges here. But the idea, what this is saying, is that any point on my ellipse, if I were to add the distance from this focus and this focus, take those distances, add them together, it's going to be that same sum for every single point. So if I were to pick another point, let's say this guy here, the distance to this focus and the distance to this focus, add together is going to be the same as that other one. This is true for all the points on the ellipse. That's how the ellipse is defined. Now, when we are drawing our ellipses, because we're looking at it in vertex form, we will actually be able to graph our ellipse without the focuses. We're not going to get out a ruler and measure and add together all this stuff. We're going to actually graph it in a very similar fashion as we would our circles. Okay, but first I want to show you this little website here that allows us to kind of interact with the ellipses a little bit. Okay. So here's one of our equations for an ellipse. You can see it's relatively similar to a circle in that we have x squared and y squared and it equals some number. For circles, we didn't have numbers on the bottom. For ellipses, we will. All right, so again, an ellipse is defined as such that the point away from our focuses, those sums are the same. So here, the distance from focus 1 to my point for this particular one is 11. The distance here is 5. Added together, they're 16. I can put this anywhere on my ellipse, and the distance now, 4.5 and 11.5, adds together to be 16. This is true for every single one of these points. You can see as the points change and the distances change, the sum of 16 stays the same. Now, is the sum always going to be 16? No. It's going to depend upon our ellipse as to what the sums are. But that's the idea of how an ellipse is created. For a circle, how did we know where the points were for a circle? What was the characteristic for circles?
Radius.
What is the radius? Good. So for a circle, we had that from the center to our points was the same. For our ellipse, it's the from the focuses to our point add together is the same. Okay. So then, again, here's another example of an equation. It's right here. As you can see, again, we have our x minus h squared plus y minus k squared. Ellipses always equal 1, though. All right, this one I want to show you the difference here. So, depending upon how wide or not so wide our ellipse is, will change where our focuses are, or vice versa. So our foci, as you can see, are pretty close to the edge here when our shape is really smushed, and not so close when it's not so smushed. Now watch what happens when my foci come together and they are the same point. AKA the center. Oh, it's a circle. Which, if you think about it, that makes sense because the distance, the sum of the distances from one foci to the other is going to be the same all the way around, and we would just talk about that as our radius. Okay, so that's a little bit with our ellipses. Let's take a look at the terminology with all this and what our different variables mean. Give me just a moment to reorient the board. So in our ellipses, we have a major axis and a minor axis. We have values A, B, and C. And we have things called vertices, co-vertices, the center, and of course our foci that we've talked about. So quite a bit of new terminology. It's going to seem like a lot of information at first, but you'll notice how it all relates to each other, and that's not so bad. Okay, so in our class, we're going to deal with horizontal ellipses and vertical ellipses. We're not going to deal with slanted ones. So a horizontal just means that it's wider than it is taller. Vertical is taller than it is wider. So this is our horizontal ellipse. Now in both ellipses, we have a major axis and minor axis. Our major axis is the long axis. So let's go and label that as our major axis. Major axis. And then this guy is our minor axis. And that was a straight line. The major axis is always the larger of the two. The minor axis is always the smaller. So in our vertical ellipse, our major axis would be this one, whereas our minor axis is I'm going to put a capital M-A for major axis and a lowercase m-a for minor axis. So the same idea, just different orientation. Now with our major axis, has vertices. Our minor axis has co-vertices. The vertices are simply where it lies on the ellipse itself. So this is a vertex. This is a vertex. The vertices are always with your major axis. And the co-vertices are where your minor axis lies on the ellipse. So this is minor, or sorry, co-vertex. On our minor axis. So co-vertex. Another vertex. The same idea with our vertical. We don't have to label all this, but our co-vertices are on the minor. Our vertices are on the major. Our center, our center here where they intersect. that's it in terms of our vocabulary. Let's go and take a look at what A, B, and C represent. So A and B are values that come from our equation. Below this, we'll take a look at that on your paper. But first, let's talk about what they are. Super important, though, is that A is always bigger than B. So A is the bigger value, and both of them have to be bigger than 0 because they're talking about distances. All right, so A, this is the distance between the center and the vertex. So A is the distance between the center and the vertex. So from my center to my vertex, call that A. It's also A on the other side if I were to go to my other vertex. Likewise over here, from my center to my vertex is A. We're always talking about your major axis there. So then what would be the length of my major axis? 2A. Okay. All right, my B represents the distance between the center and what do you guys think? Good, and no vertex. So this value here is B. Same thing over here. Our minor axis. Okay. Now our last component deals with our foci. Now our foci will always be along the major axis, so it's going to be along the wider part of your ellipse. For right now, we're just going to approximate where it is in this. I'm just going to draw a little marking here. So this is a focus. And one over here. This is a focus. And our C value deals with our focus. So our C value is the distance between the center and the focus. Okay, so if I go from my center to my focus, that's C. Similarly, on our vertical one, my focus is probably somewhere right about here. Somewhere about here. So this is still, this piece would be my C value. So again, it's the same information for horizontal as it is for vertical, just different orientation. Now our A and B value we pull from our equation. Our C we have to actually calculate. Our equation for our C value is C squared plus A squared minus B squared. Now when I go to solve for C, I would get plus or minus the square root of A squared minus B squared. But since C represents a distance, the distance, we take only the positive value. So C is the square root of A squared minus B squared. So that's something that we ourselves will calculate. Okay. Do we have any questions with our vocabulary or terminology here before we take a look at how the equations work? Okay. So for our equations, like I said, it's pretty similar to our circle equation. Again, it's really important to keep in mind that A is bigger than B, which has to be bigger than 0. So A is always your largest value of this two. Okay. So for both of these, they have a very similar setup to our circle equation. Our circle was x minus h quantity squared plus y minus k quantity squared. And for our circles, it equaled r squared. What's different for our ellipses is for our ellipses, it equals 1. We always need to equal 1. And for our ellipses, we're going to have numbers here in the denominator. Okay, now these are going to be just coefficients. No variables, just coefficients. Now, before I tell you what goes there, I want to talk about how we can determine which goes there. For our horizontal ellipse, this is what we had. Now, from our center, our major axis was left and right, so this was our major axis. What did we call this distance from our major axis to the vertices? What letter was it, A, B, or C? A. So this distance here, notice that my horizontal, this is affecting my x values. I'm going left and right. So I'm going left and right A, whatever amount that is. So because I'm going left and right, that means my A matches up with x, which goes left and right. So underneath here is a square. Okay, it's important that you have that square. And then similarly, if this is my minor axis, what do we call the distance between our center and the co-vertex? B. This is up, down, do it with our y's. So b squared is underneath my y's. So a horizontal ellipse is going to have your larger value underneath the x because it gets stretched further out on the right. Alright, so this will be very similar for our vertical one. We have x minus h quantity squared over something plus y minus k quantity squared over something equals 1. What do you think changes for this? Yeah, my b squared is under dx because the larger axis, the major axis, is going to be affecting the y's. So my a squared goes there. And my smaller axis, the minor axis, is affecting the x's, so that would be your b squared. Okay, so depending upon where your larger value is, that tells you whether it's stretched out more left, right, or stretched out more up, down.
What's K?
Oh, what is K and H? What was it in our circles? Center. The center. It's going to be the same thing for our ellipses, actually. So let's go and fill it in. Our center is HK for both the HK. And notice that it's x minus h, y minus k, so we're going to think opposite the signs. Okay. So let's take a look at our vertices and our co-vertices. I'm going to go and pull up the previous page to help us out with this. So for our horizontal ellipse here, when I go to identify my vertices, they were here along our major axis. Now we go from our center out to the vertex left and right. Does my y value of my vertex change from my center? Did I move it all up or down? No. We just went left and right, we didn't go up or down. So my y value is going to stay the same. So I take my center, I move it left and right, but I don't move it up and down. So the y value will stay the same. So I'm going to leave a blank there for my x value, but I know my y value will still be the same. Okay. For both vertices, right? We just went left, right, we didn't go up, down. Now we've got to figure out how much did we go left and right. How much do I go from my center to the vertex? What is that distance again? A. The A is defined as from the center to the vertex. So I would take my center, subtract A to go here, take my center, add A to go over there. Now again, we're doing this to the x's because we're shifting left and right. So what I have then is I take my center, so H, and I want to subtract A, that gives me my left one, and I want to add A, that gives me my right. So because we're doing horizontal here, I'm subtracting A, adding A, but I'm not going up or down at all. So my center, HK, H minus A, H plus A. But our K stay the same because we didn't go up or down. So as you can imagine, it's going to be similar for our vertical. Except now, instead of going left, right, I'm going up, down. So my left and right doesn't impact it because it's staying put. So my H value now stays the same. The X coordinate stays the same. That's not because again, I didn't go left or right, I'm just going up, down. So my H stays the same. But because I'm going up and down, that is going to affect my K value. So I'm at HK, and again, I'm still just going A up and down. So I have K minus A, K plus A. So I have K minus A, and K plus A. Okay, questions with how that came about? Alright, so you can imagine for a co-vertex, this pretty much is going to be the opposite of that. For my horizontal, the co-vertex, let's talk about my B value, so now I'm going to be adding subtracting B. But the question is, am I adding subtracting to my x's or to my y's? Well, for my co-vertex here, we're going up, down, so I'd be adding subtracting it from the y value. So for my co-vertex, x stays the same, but I want to subtract b, and then x stays the same, which is h, and I want to add b. Then for our vertical, similar idea. My minor axis, my b, is left and right. So it's affecting left and right, that's my x values. So I have h minus b, but my height stayed the same, so k. And h plus b, but my height stayed the same, so k. Let me zoom back in on that so you guys can see a little bit better. Now, for these are obviously a lot of different little equations. I don't expect you to memorize these little equations, just reason through it. Think about what you have and how it's going to affect your ellipse. Also, too, if you look, my larger value for my horizontals would be h, so it's going to affect my h. For my vertices, that's my major axis, A, it affects my h. My b value with my k, that's talking about my minor axis, so my co-vertices, it should affect your k. And then opposite for our vertical. Okay, what's the length of my major axis? 2a. If we look at our axis, a is the distance away from our center to our vertex. That's half of it, so we'd have 2a. So what would be the length of our minor axis? 2b. And this is the same for both vertical and horizontal. Because again, the major axis is always the bigger one. So I want 2 times our bigger value A. Minor axis is always smaller one, 2 times our smaller value. Okay. And then our foci is our last thing. Now our foci, again, we have to find the C value for this. And my C value is equal to the square root of A squared minus B squared. So we would have to calculate that from our equation. Notice C is not in your equation at all. So we would take our A squared and our B squared and calculate that. All right, so for our foci are always on the same major axis, or are always on the major axis. They're not on the minor, so it's on our major axis. Our major axis deals with our A value. So whatever A affects, that's your major axis, your foci is going to affect. So for my horizontal one here, A affected the x values, so my foci will affect the x values. If you think about it, we're going left and right with our foci, right? Here's my little foci. Here's my little foci. So I'm going left and right. So my foci then would be, again, it affects the axis, so h minus c, height stay the same. H plus c, height stay the same. And then it's just vice versa for our vertical. Over here, A is affecting my y's. My little foci would be up and down. So my x's stay the same, so h stays the same. But now I'm adding, subtracting it from k. So k minus c, and then k plus c. Okay, it's a lot of information. Do we have any questions on that? What questions do we have? Okay. Now, why did I take so much time to explain all of this? Because I don't want you to stuff this into your brain. I want you to be able to reason through it. I want you to be able to look at your equation and say, hey, A is the bigger one. That's going to make my y's more stretched out. That's a vertical one, which means my foci will be vertical. Means my vertices, which are my major axis, will be vertical. My co-vertices will be horizontal. Also, too, when we go to actually graph these, you'll probably not be using the equations, you'll just be counting it from the graph. But you won't always be doing a graph. 95% of the time you will be. For those other 5% of the time, you want to be able to figure out your vertices from that. Okay, let's go ahead and take a look at actually graphing an ellipse. So a lot of information up front. This part's really not too bad. It's quite similar to what we did for circles. Okay, the very first thing you must check is, does it equal 1?
Yes.
This has to be equal to 1 before we can continue in the form that we are given. Does our first one equal 1?
Yeah.
Yay! Okay, so now let's go and identify our A value and B value. A is always the larger of the two. But remember, our equation was A squared and B squared. So you already have to do a little bit of square rooting. So for number 1, what is my A value? 3. I'm going to go and just write it underneath what it's affecting. It is affecting my x's. So that's going to mean that my major axis is affecting the x's, so it's wider. So it's going to be a horizontal. Okay, what's my B value? Is 2. And there's my y, not as much, not as high. Okay. And let's go and identify our center. What is our center? Say again here. Good, very good. 2, 1. So remember the center is just hk, and it's x minus hy minus k, so you want to take opposite of the signs that you see there. Now, you could go through and fill in your vertices, co-vertices based upon those formulas, but I promise you it's a lot easier if you just go to graph it. So let's go to graph our center first. So our center is 2, 1. And then remember with circles, once we had our radius, we would just count that above, below, left, right. Very similar thing here, it's just we're not counting the same amount each time. So from my center, notice A is underneath my x's. So that means I'm counting left, right, because x's go left, right. A is 3, so I count left 3, 1, 2, 3. I count right 3, 1, 2, 3. Those are my vertices. Those are the my major axes. All right, and then my B value is with y, so B is 2. I'm going to go 2 up. This is from my center, so 2 up. And from my center, 2 down. And then we just go ahead and connect. Do the best you can with connecting. We should see it's a little smushed. It shouldn't look like that perfect circle. Okay. So now from here, it's probably going to be a lot easier for you to actually write down your vertices and co-vertices. You can just grab it from the graph. So my vertices, just make sure you have the proper ones. Vertices are the further away ones. So my vertices would be -1, 1. And is that 5, 1? Now, the formula said that since A affects my x's, I'm just going to take my x coordinate of my center and subtract and add that. So 2 minus 3 is -1, 2 plus 3 is 5. You can do it that way or you can pull from your graph. Alright, so then my co-vertices, it looks like we've got 2, -1, and 2, 3. Is that what you guys got? Did I count that correctly? Yes, I got 1 confirmation, 2 confirmations, 3, 4. Okay. What's the length of my major axis? 6. Good. 3 to the left, 3 to the right. My minor axis. Good. So that's what you got. Finally, we have to do a little bit of math for our cosine. So we have to first calculate our c, which is square root of a squared minus b squared. Notice it's the squareds. What was a squared again?
9.
And b squared?
4.
Okay. So our c value would be square root of 5. Now, when we go to write our coordinates for the foci, we will use the radical. But when we go to graph it, we have to have an idea of about how much square root of 5 is. Pretend you didn't have a little blue calculator on your desk in front of you. About how much would root 5 be?
2.2.
2.2? 2.25. We're getting super exact. How do we know that it's about 2.2-ish? You're going backwards, or you're going the opposite direction.
That's 2 is 4, 3 times 3 is 9, so it's about between the more than 4 and 9.
Oh, very good, very good. So our perfect squares, that's in between is 4 and 9, close to the 4. 4 is 2, square root of 4 is 2, square root of 3 is 3, so between 2 and 3. Good, so I like 2.2-ish. I'm going to say it's about 2.2-ish. Very mathematical there. Again, the ish is only used for graphing. We use the actual radical for our coordinates. I'm going to first graph it. 2.2-ish. So this is on my major axis. So from my center, I want to go, again, it's on my major axis, so I'm going left, right. So I want to go left 2.2-ish and right 2.2-ish. Now when we go to actually write our foci coordinates, we will actually write it using that. Our foci, our C value affects the same thing our A value affects. A is with X, so C will affect X. So I just simply took my center, and I went 2.2-ish to the left, 2.2-ish to the right, or square root of 5 to the left, square root of 5 to the right. So I take my center, and I'm going left and right, so it's 2 minus root 5. Our y value stays the same. So that went to the left. And then to go to the right, that'd be 2 plus root 5. Our y value stays the same. If you write 2 minus 2.2, you'll be wrong. Okay. Questions with that? So even though foci is used as a large part of our definition for ellipse, as you can see, if we have it in this nice form which we call vertex form, then we can graph it using the other information, and we don't have to individually find each point on it from our placement. Okay, let's go take a look at our next one. Does it equal 1? No. Big time issue. What can we do so that it equals 1 and still maintains this similar format here?
Square root.
So if I square root the 144, what is square root of 144? Well, so it's not 1. But also, then we have square root of this. Do I want a square root over here? Do I want a square root over here?
143.
I like that idea. If we subtract 143, would we get 1 over here? Yes. But do we have anything add or subtract at the end of this? No. So we don't want a constant at the end. David? And never mind. What else? Divide by 144?
Yeah.
Okay, if I divide by 144, does that give me 1?
Yeah.
Okay, and then let's see what happens over here. I think we need to do a little bit of math first for this. We will have to divide both pieces by 144. Okay, pretend you don't have the blue calculator in front of you. 16 over 144. Ooh, what goes into both? I don't know, but I know that 144 is divisible by 12. Is 12 divisible by 4?
Yes.
And 144 must be divisible by 4. So I know that 16 divided by 4 is 4. The question is, what's 144 divided by 4? 4 goes into 18 3 times.
36.
And then 4 goes into 24 6 times. Okay, what's 16 over 144 reduced down to?
1, 9.
Good, 1 9. Okay, so that means that 16x squared over 144 would just be x squared over 9. What about 9 over 144?
Easy.
If 16 over 144 was 9, 9 over 144 would be
1, 16.
So when you say 116, do you mean like 116 or 16? You're thinking.
I don't know.
Let me know which side.
Yeah, 1 over 16.
1 over 16, that is correct.
I guess.
It's the biggest right now.
And yes.
So 16 divided by 144 left us 9 in the denominator. 9 divided by 144 leaves us 16 in the denominator. 16 divided by minus 144. Okay, so did that keep it in a similar format to what we had over here?
Yes.
Yeah, what does look different though?
It doesn't have a K or an H.
Good, it doesn't have a K or an H. So then what is our center here? 0, 0, very good. So remember that back from our circles? There's no value that's subtracted away, so our center is 0, 0. All right, let's go ahead and plot that sucker on our graph. And we need to identify A and B. Remember, A is always the bigger one. What is my A value?
3.1.
Close. I'm going to go with the 4. So this is b squared and a squared, so that's why we have to take the square root. So I have this is 4, and this one would be 3. So a is 4, b is 3, a is always the bigger one. Our general equation is a squared and b squared, so we have to square root those. Alright, so let's just go and plot our vertices from here. Alright, a is 4, what is that affecting? Up, down, or left, right?
Left, right.
class divided? Is it left, right, or up, down?
Left, right,
Why is it left, right, Kathy?
because it's they come right because it's under the Y.
Our A value is under the Y, so it would be up, down. So we're going to go 4 up and 4 down. Now my B is underneath the X's, so that's left, right. So 3 left, 3 right. This is always from our center that we're talking about. Go ahead and draw on that potato. Oh, trying to hit your vertices. Sorry guys, I'm going to stand in front of it. Okay. So now we should be able to fill in our vertices, co-vertices, our length of major, length of minor. I want you guys to go try foci. So I want you guys to go try and fill in that rest of that there. Calculate that foci. Where will our foci go? This is actually your final, which is remember that when you're calculating your C, it's A squared minus B squared. So we're doing 16 minus 9, not 4 minus 3. Okay, go check your answers for your vertices, co-vertices, length of major, length of minor, and your foci. I got a C value of square root of 7. Is that what you guys got?
Yes.
About how much is root 7?
2.6.
2.5. I'm going to go with 2.6. I like that it goes a little heavier. So I'm going to say about 2.6-ish. On my graph, I'm going to be looking that we go 2 and a little over half-ish. Again, we use the radical for our foci coordinates. We use the ish for graphing. Do we have any questions with this one? Now, what's nice with these ones when the center is 0, 0 is it's a lot easier to calculate your foci and your vertices and co-vertices. Before, for our previous foci, we had to do 2 minus root 5, 2 plus root 5, and those didn't reduce. Here, we did the same idea of looking at my y's now. Because a affects y, so my c will affect y. 0 minus root 7 and 0 plus root 7, but those did reduce down to just negative root 7 and positive root 7. That's why it doesn't look quite as complicated as the one before, just simply because we start off with that 0. Okay, so take a look at number 3. Does this equal 1?
Yes.
Sweet. What's missing though?
We're
We're looking for either that A or that B value, right? So this needs to have a number underneath it. What should be underneath it? 1. Can we divide by 0? No. So remember, anything over 1 is itself. So it's just over 1. You can just go and set it all in my chair right there. You just set it all in my chair right there. Alright, so what's my A value going to be? Good. What's my B value? And now, the ultimate question, what is my center?
Oh, your center is 2, 0.
Close.
What? No, it's
Negative 2. Negative 2, 0. Good.
No, wait, yeah.
I know it's hard to believe, Kathy, that you could possibly maybe not be quite as correct as all the other time tests.
That's right. Something wrong?
What? I don't think this is the only time it's going to happen in his whole lifetime.
Yeah.
Alright, so our center is negative 2, 0. Remember, this y doesn't have anything with it, so that's at 0, and it's x minus negative 2. Okay, so we plot our center negative 2, 0. Our A value is 5. Am I going up, down, or left, right for 5? Up, down, underneath the y. So it's up 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5. My B value is 1. That's with x. We go left 1. Right, 1. Oh, we've got a nice little skinny ellipse here. Okay. So my vertices, we've got negative 2, negative 5, and negative 2, 5. Co-vertices, negative 3, 0. 1, 0. Length of major. Length of minor. Good. Alright, so our foci is equals the square root of a squared minus b squared, which is the square root of 24. We do need to reduce this for our coordinates here, but let's use this to approximate it. If it's square root of 24, about how much will that be? 4.9. It's got to be really close to 5, right? So 4.9-ish. I'm almost to the edge. Almost to the edge. It won't ever actually be a vertex, so just go close to it. But we do need to go ahead and reduce this. So 4 plus 6, 2 and 3. So that's really 2 root 6. So for my foci, and that was up, down. So my x value stayed the same. So I'm looking at up, down. So 0 minus 2 root 6, which is negative 2 root 6. And then 0 plus 2 root 6, which is 2 root 6. That's it. Okay. Questions with that? So remember, we're following the yellow sheet now. So our homework is Ellipses Day 1 homework, which I'm passing out to you now. On the back side, it does ask you to graph the ellipse, but does not provide graphs, so just make sure you grab some graph paper for it. Or if you just want to do your own rough sketch of a graph, that's fine as well. You're just going to draw out your coordinate axes. Those of you that weren't here for the entire class, the notes here are already up on Blackboard, and there's a video of the lesson as well. Go ahead and return my blue calculators if you would, please. I think in the orange store there might be some separate calculators. When the bell rings, when the bell rings. All right, so your homework is at Ellipses Day 1.